So next speaker will be Ulrik Beste, Chief Technical Officer from VB Components AB. So his title is a new materials through additive manufacturing. So he will give an interesting view of utilizing electron beam melting to produce new type of materials. So Ulrik, please.
Yes, hello everybody. I will share my screen here. So now we can see me and a picture of me. Unfortunately, the video camera doesn't work for me either. Thank you very much for inviting me to this, and I also say thank you to the very interesting talks before me. I'll try to continue in that direction with interesting talks. Very short about VB components, what we think that we can do for the nuclear sector. We are a part company. We can deliver parts in near-net shape in our Vibinite materials. For examples, for valve houses, rings, impellers, or wear parts. We have extreme materials in many ways. I will show you more about that. But for example, we have the world's hardest steel with a hardness of 72 Rockwell, which we can print, and which is what we're doing today. We can make complex shapes. You already know about this, but in this case, we see that we have one possibility, for example, to easily provide holes for a sensor in a tool or a component in the hard alloys that we print. That is just an idea what we can do, and I see that, for example, in a valve or something. Short delivery times. You already know about this in the additive manufacturing. All the process steps are highly reduced, and we can also, in the end, we can provide you with the license solutions for manufacturers that would like to use the technology in-house for larger series, for example. Cost savings. We have proven that we can save a lot of materials with our Vibinite manufacturing technique. And what we are focusing on always in our material development is to have high-end productivity on the components or the tools that we produce. We don't need the machining, and this is also for this extremely very difficult to process materials, and I will show you more about that also. But this is one of the biggest benefits with this technique, to use this technique on very, very wear-resistant materials. And the turnaround time for prototyping is very fast, as you already know, also in the additive manufacturing arena. What is we? VB Components, we have been active for more than 10 years, and we are focusing on wear-resistant materials, and we are developing materials for the suitable additive manufacturing machines. And we have a number of years in tribology field and also in material science field. And we are located in Uppsala, Sweden, where we have a additive manufacturing production unit. We are, as I said, focused on new materials. We call this material Vibinite. And today we are using the electron beam melting technique. And that is most suitable for us at the moment. But you know also that the techniques are highly and quickly developing now. So we can switch to something else in the future. But today we're using the electron beam melting from GE Additive. Typically, we deliver a hardened near-net shape blank to a customer, or we can also provide with a subcontractor, we can do the finishing, grinding or EDM or what is necessary for the end component. This is highly dependent on what your needs are. And we have a printing size in our machines that are approximately 230, 230, 380, something like that. It's not only the machine chamber size that sets the limits. You also have a problem in some components. You cannot print extremely much in some cases and so on. It's just to ask us. That is the easiest way. Send us a drawing. So why should you 3D print wear-resistant metals? Well, you have all seen the traditional manufacturing process, and you also know how this is manufactured typically today. There are a number of process steps where to provide a material, to provide a bar in the steel plant. You need to compact powders, you need to forge and roll and everything about this. And then you have the bar logistics. You have to travel the bar everywhere to a warehouse, and then you have to cut a part of the bar before you can get to the machining shop. And there you start removing the materials which you have done before. And you take away all the very, very wear resistant materials. And then you get the finished component. And what do? Then we take the powder, we do the additive manufacturing of a blank, we heat treat it, and then you need to grind it or machine it or EDM it, and then you have a finished component. This is what we are talking about. This is the big paradigm shift in metal making. And this is especially efficient when you're looking at very, very wear-resistant metals. We have a Vibinite material group. We first start presenting 3 of the alloys, which are high-speed steel alloys in different hardness. We have Vibinite 150, which is a softer high-speed steel grade. 280, which is our oldest alloy, which we have been working with for the beginning. And then we have the Vibinite 290, which is the world's hardest steel with very, very high amount of wear-resistant carbides. Then we have the Vibinite 350, which is a corrosion-resistant and wear-resistant steel. I will show you more about that. Then we have the newest and the biggest invention at the moment, and that is the Vibinite 480, which is what we call a hybrid carbide metal, which is the first commercially available 3D printed cemented carbide. I will show you more about that also. And then we're working with Vibinite 130, which is our softest alloy, and this is similar to the traditionally used H30, which is the most common tool steel. So it's coming up. We have a number of projects now running with them. If we compare Vibinite with other additive manufacturing materials, then we do like this. We use the graph from European Powder Metallurgy Association, and then we put in the existing AM alloys and look at the hardness and the yield strength. Then you can see that here you have the typical steels and titanium and cobalt chromium alloys that exists today. Here in this region, you have a number of more aging steels, which are also very good for the applications. And here we have the Vibinite alloys. So we are in a totally different scale of hardness and wear resistance. In addition, these alloys also include a content of carbides, which is also very interesting, of course. So the hardness is one thing in wear resistant, but the carbide content is an add-on to that. We look into Vibinite 350, which is what we think is a suitable material for nuclear application. It is a alloy, it's a steel alloy with high chromium chromium content. So you get both wear resistance and corrosion resistance. And today we have a hardness of 60 Rockwells on this material. So it's a good combination material. That is the major thing with this material. We always have fine microstructures, fine carbides, and we also have very, very high cleanliness, and that is the low oxygen content. And that is a patented technology of VBM to reduce the oxygen content, which you always get high when you have powder materials. You need to reduce the oxygen to get into the good fatigue properties, for example. This material we have developed together with the support for the Swedish Energy Agency, which they understood the big possibilities of saving energy and material. And the applications, of course, are valves, pumps, turbines, marines, and also plastic processing tools, etc. So we believe that this is a very good alloy for nuclear applications, especially since it's totally cobalt free. that has been one of the ideas behind this alloy also. We look into another alloy. This is the Vibinite 150, which, as I mentioned, it's the softest alloy what you have today before we release the new one alloy. This is also a wear-resistant, very fine-grained material with very fine carbide content. So also this is a very interesting alloys. And what we have seen that we have a very, very high fatigue resistance thanks to the cleanliness and the fine microstructure in the material. And just to show you one thing, very technically, one of the fatigue measurements we have done on the Vibinite 150. We have pull-pull fatigue testing, staircase method. Then we have a fatigue stress level of about 1200 megapascals. And it's also uniform if you print standing test bars or lying horizontal test bars. You have the same fatigue stress level. This is an indication of a very good process to manufacture these materials. And what I heard, this is about twice what you can find in another additive manufacturing today. Vibinite 290, this is the world's hardest commercially available steel grade. We have a hardened possibility up to 72 Rockwell. Also here we have fine microstructure and fine carbides, and we have a high hot hardness and very, very good wear resistance, of course, with this. So here you can use this in a number of wear applications. And typically, it could be cutting tools, gear hubs, broaches, etc. But also it could be any kind of wear-resistant needs. And the good thing is, of course, with additive manufacturing, you can process very difficult shapes to add into your existing components where you need wear resistance. Vibinite 480. This is the world's first commercially available 3D printed cemented carbide. And we have another idea behind this, because this is not a cemented carbide, but it is in the range of cemented carbide. Because we do not cement it, we don't have any sintering or binding process as you have in traditional tungsten carbide cobalt grades. So we have done this from pre-alloyed metal powder and EBM technology. Then we can reach a hardness of 67 Rockwells and very, very high amount of carbides, which you can see here on the microstructure picture. And the basic major idea with this alloy was to close the gap between high-speed steel and cemented carbides, so that you get much better heat resistance, hot hardness, and still toughness that is very good for your applications. And typically tooling is one of the biggest areas, but of course you can use it in any kind of applications where you need both heat resistance and wear resistance. And I will show you an example of benefits here. We have a component that is roller bearing rings, and we start with the increased end performance, and that is due to the high patented metal cleanliness. So we get a very, very good long fatigue resistance in this. And you can also use the additive manufacturing for smarter design, and you have a through hardness through the component that is very important. So you have a uniform material that in your application. Then you simplify the production, and of course, if you need a highly alloyed material today, you need to buy a bar. And to do that, to do a ring from a bar, you need to remove about 90% of the material. And the higher hardness and the higher wear resistance, the more difficult it is. But from buying from Vibinite, you can get a ring. And you can also get a small ring diameter or a large ring diameter. And that is something that is totally not possible today. You cannot buy a very, very big bar in extremely highly alloyed material and remove the material to make a ring. You don't do that. So, in general, it's the less process steps that are the big thing. Then to get the customer to succeed with this, they need our advanced customer support. So we have been around so many years now with the expertise in tribology and the material knowledge and additive manufacturing and how to design. So we can help you with that. And finally, of course, it's very environmentally friendly. We reduce the material consumption very, very much. We reduce the energy needed in the process, especially when you add the end performance on the component. So also the less heavy transport you need, you don't need to run the steel bars on trains or lorries everywhere. You can just have a powder batch and so on. And it's much quicker development to better products in the end, which is the most important thing in some way. We offer this to our customers today. We typically, a customer starts with a standard pre-study. And that is the first technical discussions. We help with the drawing and we help you with the printing of the first components so that you can test in real life. If you are needed, we can help you also with analysis of your existing component to understand more about the wear mechanisms you have today and the best solution, the best material choice. Or we go to the AM utilize pre-study, which we help you to use the additive manufacturing technique to improve your performance in the components. And then the most common question we get is how cheap can it be if we buy many of these? And to give you a good answer on that, then we need the production development project, which is about to do a number of trials and see what we can do to pack the machine and to reduce the printing time. Then we need to do this a number of times before we can say that. Or, of course, a direct print. This is just if you send us a drawing or a component that you need us to 3D scan or copy, then we can help you with that directly in our materials, of course. And then we can do the small serial production when you know that everything works. You would like to buy something on a regular basis, but you are not interested in having your own production, then we can help you with this. Or you can buy a licensed solution for us from a large serial production. And then we help you with everything. We recommend which machine you should buy, and we recommend all surrounding equipment. We come with the settings for the printing file and so on. So then we can do everything for you. Some examples, just to summarize up here. We have examples of metal casting tools with cooling channels. I don't know if you can see that with the resolution, but these tools are 365 millimeters tall. So the weight of one of these are about 34 kilograms, which we have printed. And then you need to combine them for this tool here. Forming tools, we're now working in France and Germany with forming tools for metal sheet metals, so you can use this technology. This is just a part of them. Compressor screws, it's also available. You can use this wear-resistant materials. This is how they look before grinding, of course. But you can use this technology for having wear-resistant complex shapes. And then you have seen this many times. I have it on the first slide also, the lightweight metal cutting tools where you can use the high heat resistance of the materials. And you can reduce the weight of them and save materials and so on. Food extruder is an example. This is from Orkla, which they are extruding cheese doodles, which is an important product of today. And then I can finalize with to show you the Vibinite combo, which is just to show that what's possible with this technique. Then we have combined the two materials. Then we start printing a cylinder with the Vibinite 150, and then we switch powder in the machine, and then we put this into again, and then we print the Vibinite 290 upon it. and then we harden this component so that you get different properties and different hardness in one piece. This is just an example of what you can do. So this is, and now we have a number of customers asking for this in different applications. Thank you. That was my talk. More questions, please.
Okay, thank you so much, Ulrik. Really, really cool examples of materials and applications. I was actually wondering that as a part of your kind of service, do you sell these powders out, or is it more like that you produce the parts for your customers? So you kind of explained this briefly, but that was a bit unclear for me.
Yes, good question, and this is also one of the most common questions. Can we buy a powder? And the thing is that a material is a result of two things. First, you have the powder, the composition of your alloy, and then you have the processing technique. And to get the microstructure and the cleanliness and so on, then you need to do this in a certain way with the process settings. So if you just buy a powder from us and put it in a machine, then you don't know how to print it directly. But we can help you with this. So this is it's possible. But today we do not sell the powders freely because you don't get the final properties from that.
Okay.
But it's just a question of how big wallet you have, if it's possible, of course.
Good, thank you. Then I have an other question too. So the maybe the EBM technology is not known as a kind of the most versatile AM technology when it comes to material properties, or at least there is a kind of quite common understanding like this. So I was wondering if you could briefly kind of explain that why you have selected this technology, and kind of that what highlights come from this technology.
Yeah, we started, as I mentioned, more than 10 years ago with this. And in that case, we went around and tested different techniques. And then the EBM technology was that we succeeded the most quickly in. And it's due to two major things. And that is the heat. When you process something in the EBM machine, you keep your component very, very warm. And that is when you produce hard materials, which also are more brittle than the top material, then you need the high temperature. And also we get a very, very high cleanliness because everything is produced in vacuum. And that is also one thing. The laser machines today typically don't have a vacuum. Of course, it's possible for the new machines coming up in the future. But the major thing is the heat and the vacuum, so that you get a very, very good material properties. On the other hand, of course, we have, as everybody already know, that we have a more rough surfaces than typically you get in a laser machine. And this is a plus or minus typically. But for these alloys, they are so extremely difficult to machine, especially the Vibinite 350. It's a very, very difficult alloy to machine if you would buy it from the bar. And in that case, you can absolutely easily work with a rough surface. That is not a problem.